Hello everyone, good evening. My name is Dipanshu and I have come up with a new video which I was getting a lot of queries basically these days. First of all, I would like to thank you everyone for giving so much of love and and support to my previous videos which I have uploaded. I'm getting a very good response from all of you for the support that you guys are showcasing, especially to my last videos, which is on P32 ransomware, Emotet, and Docker Forensics. I got a lot of appreciations and comments for the video which I posted on Docker Forensics especially. But I was getting a lot of questions on on things on things how we generally start with the memory forensics. Okay, digital forensics is one topic which generally covers each and every part, whether it is the operating system, memory, Android, or, iOS, your Linux machines, your Windows machines, cloud, each and everything. But these all things are based on the logging mechanisms for which logs are always being enabled. You are collecting logs via third party tools, you are collecting logs directly from the machine events, syslog, and so on. But why memory? Because why memory forensics is so important and very critical for, part of digital forensics? Because nowadays what attackers they target is the memory. Okay, even in when I restarted my YouTube channel after 2015, when YouTube shut down my YouTube channel in 2015, I started my YouTube channel again in 2020, but I didn't upload much videos. I think only like three or only like very few videos. Okay, just and especially those on malwares, because developing malwares, bypassing the EDRs, email securities, via phishing, compromising users, performing red team was my forte and is still my forte. That is why when I'm performing the malware analysis, I know what functions to look for, what offsets to look for, where I will get the ransomwares registry files, where I will get the malware's persistence, where I will, because I know how attackers things generally work, how the encryption stacks will work. For an example, in one of my malware analysis, when I was showcasing, I showcase you a very old ransomware, a very old encryption technique, in that the attacker has used it, because that was very immature, what we call it as encryption standard. But when I saw it very first time, I was also surprised. Okay. Also for memory forensics, what I have seen when I was practicing these digital forensics, malware analysis, and malware development when I was learning during my college days, I also faced a bit of difficulty of finding the right set of tutorials on internet, because this is present on internet for free, of course. There is no money that you have to spend for it to learn these things, but these are present in bits and pieces. For an example, for each and every ransomware or malware or any injection attack that is happening in your operating system is always bit different and unique from each other, because every attacker style of developing malware and injection is always unique. Okay, and is very because every attacker's first primary goal is to bypass the security solutions that are present on the operating system or in any organization. For an example, the very first layer that hits when you are sending phishing links is the email security. So bypassing email security, especially when they are connecting with the sandbox over there, each and every email, each and every link, each and every data packet that you are sending on emails, they are always being sandboxed and are always analyzed automatically by the sandbox that is present over there. For an example, that hits the firewall. Firewall are coming with the inbuilt sandboxes. I know the firewall sandboxes are not of that level strong, which sandboxes manual engineer configures on his machine. Like I have configured my uh, sandbox, which is based on the Cuckoo sandbox overlay on the Kappa and configured with the Mist. But the firewall sandboxes are also very useful. I have seen many times when threats are coming in my organization, especially via some emails or something, when communication starts, firewall do analyze those communications in the sandbox. I know I will get a lot of questions, and I might get pushbacks as well, where the engineers or the analysts will say that the communication is bit of slow in every organization and they generally switch it off. Yes, they generally do it, but if you go to serious organizations where government is included or payments are included or the customer base is so strong, those organizations are definitely holding it up and using it. So I got almost like many queries. I cannot even count the numbers, and from so long I was getting these queries that please create some videos on memory forensics because this is very critical. Also, another reason for memory forensics why it is critical, not only because it's present in bits and pieces on internet, or it is very very tricky. Also, it is very important from digital forensic because the days are gone where things are being stored on hard drives. The hard drive is only for storing the either the initial payload, okay, which will connect to the C2 server, which will start downloading the malware on the RAM, on the memory via some PowerShell or command prompt, and then it will start exploding the communication. It will do the exfiltration, perform persistence in the environment using some DLL injection or process following or maybe code injection or something else. So I have these type of attacks I have already covered in one of my playlists called as malware. So do check all those videos. They are presented with some specifications that I have also presented one video which is based on code caving, which is generally my style of developing malwares. That you prepare a shell code which is completely bypassed from the EDR. You scan it, the EDRs, you scan it using certain EDRs which are there on internet, and then carved it into some executables using Putty or maybe Mozilla Firefox, you know, and then you start exploring those malwares and start distributing those malwares. Okay. So without wasting any more time, we will start with memory forensics, which is end-to-end threat analysis for threat hunters. This video will cover each and every point. After this video, you will not have to look for any other tutorials on internet. Yes, to practice other tools, you might, because I cover specific tools which I use in my daily life. I generally use command line tools and I am very, very happy using that because I can develop my own plugins. I can develop my own scripts. I can develop a lot of things in that. That is why I generally use, open source with tools with command lines. But feel free to utilize any other tool if you want to. You are free to use that. For that, you can look for other videos. But for information, how to start, what is included in memory forensic, what to look for. After this video, you don't have to look for any other thing, any other video. So let's start with the memory forensics. Memory, when it comes to malwares or malware analysis, is always referred to the RAM, which is random access memory, which is nothing but a volatile memory that stores or temporarily holds data and programs which are being used by the CPU. Okay, and this is being taught in third or fourth standard in schools. I've been taught this in the third standard, what is RAM, or maybe in fourth standard when we started with the computers, the basics of computer where we used to draw the computers with the pen. I started with Pentium 4 when the P4 computers were there with 128, I think, MB of RAM or some 10 GB hard drive with which I started when the game Dave was very popular. I started using those days. So whenever a program runs, what happens? CPU interprets instructions, then data and code are loaded from storage into RAM using bootloaders. I forgot to write over here. You can call it as the bootloaders, either it is on Windows or if Linux, it is the grub, which is nothing but the grand unified bootloader, which is my first hack, which I presented in HackCon when I was, I think, 18 or 19 years old. Uh, uh, and that was the first hack which got me very famous in India and outside India as well. And after that, I published my another hack where I broke the MD5 algorithm. Not broke basically. I did the collisions in MD5, which I presented in DEF CON, ToolCon, and many other conferences. So then what happens is RAM provides fast access, enabling efficient execution. Now, generally, when it comes to operating system, memory is being referred to RAM, but there are other types of memory as well, which are very important from forensics point of view because the 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 main part of threat hunting is always the log collection. If you do not collect the logs in the proper format or in the or properly, you 100% chances are there you will miss out of some things because you can collect images. Because why memory is being tricky, I will tell you. This question I generally ask during interviews as well, and when I used to give the interviews as well, this question generally being asked from me as well, that why memory analysis is tricky. The reason is because collection of logs. Because in operating system you can create a full image of the operating system. When it comes to cloud, your logs are always present on either Azure AD or via IEM logs. You can look for if you are using AWS, you can look for CloudTrail logs, CloudWatch logs. If you are using Azure, you can actually look for VNet logs, VM logs, and you can store it in Event Hub, and then you can start analyzing it. And in that you will get the firewall logs, machine event logs. You can get third party logs, okay, logs from the third party tools. But when it comes to memory, collecting memory logs is very, very tricky, okay, because we sometimes need to pinpoint to understand the type of malware we are hitting with. Now, this Medusa is already a known malware or a known ransomware, okay, but what about the new ransomware which is coming on? Because now I know what I need to look for. But when it comes to new ransomware, it takes a lot of time. It takes days to analyze and understand the behavior of that particular ransomware. Of course, you will get the IOCs. After getting the IOCs, you can definitely stop the attack. But what exactly built is inside that particular ransomware or memory, you either do the reverse engineering, which is very difficult because what you get in the end, that the whole executable is always encrypted. So the only thing that left with you is the capturing of the memory. Okay. So memory capture is always tricky and important because you need to look for what logs you want to collect it from there. But after this video, it will no longer be difficult for you. So what type of memories? Basically in any operating system or maybe older versions of the RAM or something. The very first is the cache, which is fastest small memory in CPU for storing the temporary data. You might have heard from this your IT guys that to foster the operating system, always remove sorry to when something is not working in browser or in the operating system, restart your operating system or remove the cache temp files, remove cache cookies from browsers, all those things. So this is that cache basically, which holds the temporary data for faster processing of the data into the memory. Then RAM, which is the current version is I think DDR4, which is the main volatile memory, which holds the operating system applications active data. DRAM, which is dynamic RAM, which requires for refreshing the data cycles. Then we have static RAM, which is faster, costlier, and is usually used in CPU caches. Then we have Rambus RAM, which is a very old technology, which was used as the high-speed RAM. Then we have ROM, which is non-volatile memory, and which is used to store the firmware. Then we have PROM and EPROM, which are nothing but the programmable and erasable PROMs used for firmware and BIOS. Then the order of volatility. Order of volatility is very important when it comes to memory analysis, because in this way only you have to collect the logs. Now you don't collect the logs manually anymore. The tools does the part for you. But when it comes to understanding, and when you will be analyzing the injections inside the memory or the malicious memories, when you will be analyzing, you have to follow this order only. Okay, because starting from one, from here only you will come to know that what is exactly happening inside your environment. Okay, otherwise what you will end up will be you will be keep on missing some of the data, some of the logs. You might miss some of the instruction points, you might miss the stack pointers, you might miss the calling of the heap memories, or and so on. So this point is very, very important, that you follow the order of volatility very, very carefully. When it comes to collection of logs, you don't have to do it manually now. The tools does for that, and I will showcase it to you. So, what is the order type? The first is the CPU cache registers. Then you have the memory, which stores the kernel stacks. Then you have process tables, which generally store network connections. Then you collect the logs from the disk, which contains the files or some other type of logs, maybe some web server logs, or maybe some uh, running system logs, machine events, and those sort of stuff. Then you have the remote logs. Then you have configuration files and all those stuff. Then you have backups and archives. And this is the order with which the logs are generally being collected, and they are being analyzed when we are doing the memory analysis. But why memory forensics? This question is very, very important to identify the stealthy attacks such as fileless malwares, code injections, etc. And I have covered this in a lot of my videos in 2020 or 21 or maybe 22. I don't remember much, but you can look to the playlist malware. I have showcased extensively in that particular playlist. Uh, and one of the most critical one I have showcased is the code caving, that how the real malware developers, how they store the malwares in tools like Putty, Mozilla Firefox, and so on. Okay, so fileless malwares are very popular these days, because what they do is they don't run anything directly from the hard drive. They just it is just the initial payload which you click on. The rest of the things are being once it connects to the C2 server, it start downloading the droppers on the machine. From there, the payloads run, or I call it as a stub. The stub start extracting its payloads, and then it start running from the RAM. It might create it might has a DLL injection. If I follow the style, I will do the DLL injection or some code injection or maybe process following or some other type of attack, to create a persistence in the machine. Once I create the persistence, then I will connect to my C2 environment completely. Once I connect to the C2 environment, then I will create a stealthy mode, and then I will do the data exfiltration and so on. And to understand these things, you have to learn the memory forensics. You should know the memory in and out, how the stack runs, how stack stores the data, how heap stores the data, how the files are being loaded into the memory, what will be the stack addresses, what is the offset value, everything you have to understand. What is the root cause investigation? Basically, when you have to provide the RCA, root cause analysis, for any sort of incidents. Live IOC extraction. Yes, the from the dynamic memory analysis, which I have showcased in my previous videos. You can refer to those videos like Emotet, P32, and Agent Tesla. The IOCs that you are getting is directly from the dynamic analysis or the static analysis, but when it comes to the real strings or real indicators for compromise, they generally come from the memory only, because there is the place where the stack stores the data strings, which are being executed inside the EDR cap, which are usually to bypass that EDR cap and create a stealthy mode inside your processes and the threads which are executing on the operating system. Then, of course, when you have to file a case or make a legal compliance, you need it as an evidence gathering, and and of course, it gives you an open eye or a bird eye view on on the threads which are not stored on the disk, even not on the in the form of temp files or encrypted files, and because the malware, they are running live only in the memory. So there are memory acquisition process that we generally follow, but I generally prefer the local memory acquisition, because that will give you 100% satisfaction that yeah, you have collected the complete memory and the kernel stats as well, which will include your registry files, registry keys, and your hives and all that sort of stuff. So there are usually four types of storages: local versus remote, which is decided based on the access scope. So, for an example, any incident happened in some remote country, but you are sitting in India, and you have to collect the logs. So what you do is you follow the remote process. But generally, what I used to tell to my friends, or when I used to collect the logs, what I do is I generally take the remote session and then I run the local tools to to collect the data, because at that time you also have to take care of one very important aspect, that you do not interrupt the memory, okay, that you do not interrupt the running processes, okay. So when you are running it remotely, many times you might encounter this thing, that the memory get overlapped and overwritten, and or the memory leaks are happening, and then uh, you know, and chances are that you will lose some memory offsets. Okay, and losing those memory offsets can result in losing the actual logs. Okay, then you have physical acquisition, which will be full RAM dump, example raw dot in the form of dot raw or in the form of bin. This is the local acquisition only. Okay, when you have the physical device present with you and you are doing the acquisition, then you have process memory that will only target those malicious processes. But generally, I do not recommend this, because the malicious processes, what they generally do is to perform the persistence, they generally get persistence into Explorer or some notepad file, or some already running processes into browsers or some other threads. So generally I do not recommend this, and by running the live commands like you will extract the memory residence data using some live tools. So what are the challenges in the memory acquisitions? Deadlocks or hangs, when it is very critical that the machines that you are targeting, they should not go into any deadlock situation. If that is the case, it will become almost impossible to collect the memory from the infected machine. Page faults, accessing non-resident memory, RAM encryption, especially in modern systems, you will see that the memory itself is encrypted. Then cache data extraction, IoT device constraints, or some data integrity with hash verifications. And there is also one point which I wanted to elaborate in detail, which is the reboot sustainability. Now, what happens is generally what I have seen in many organizations or IT guys, what they do is that they reboot the machine as soon as they see it infected. Now, as soon as you reboot the machine, there are high chances of losing very critical memory offsets, which might contain a very critical data strings or infected malicious strings, which can give you a very critical information about the attacker or the running ransomware or malware on your machine. So why reboot sustainability? Because RAM is volatile, so data is lost on shutdown. There are high chances for that. Artifacts like malware code, keys, credentials often reside in memory. Always acquire memory before reboot. If already rebooted, there is a tool like Afterlife, which will attempt to recover the lost data. But I have seen and I have dealt uh, in real life as well that you often lose some critical memory locations which might contain the evidences. So there are many tools available in the market, like magnet ram capture, DumpIt from Monsoon. This is one of my favorite. Recall, this is also very good. Then Balcaset ram capture, this is being used in most of the organizations, even in the defense agencies. If FTK Imager, this is also being very famous and being used in many organizations and defense agencies. Okay. Then we have memory analysis tools, which are Volatility 2, Volatility 3. Or I generally do all my memory analysis using Volatility 3 because what what my thing over what my why I like this Volatility 3 a lot, because of custom plugins that I can write. So for an example like this, I will come to this when I will be running this particular plugin file, which will automate the complete malware analysis for me from the memory. So I don't have to run the complete analysis one by one. I just run this particular file, and all the things are being done inside the by the shell file only. And I will demonstrate that as well. And I will upload it on my GitHub. You can refer it from GitHub, and you can customize it, write it. It is available as open source. Then memproc fs, this treats memory dumps like a file system. I have seen many people using it, but I generally don't use it this much for malware analysis, because of always you have some personal choice for using it. I generally prefer volatility free. Then we have Uruchi, which is similar to Memproc FS, but it is a GUI version of the volatility. It is similar like volatility, but in the GUI version, for easier navigation. But what Volatility 3 provides you, no other tool will provide you. That is my 100% guarantee to you, because you can rewrite plugins, you can write your own custom plugins, Yara files, and so on. And I will demonstrate that as well. I have written custom Yara file for Medusa as well, like P32, Agent Tesla, Emotet, and other ransomwares or other malwares. For this also, I have written a custom Yara file which you can embed in your Volatility 3, and then you can look for the Medusa artifacts. So going into the before doing our hands dirty, I would like to clear some concepts for memory management, which is the static and dynamic loading, which means that malware will hide dynamically in loaded modules, which is your what we call it as the DLL dynamic loading, DLL files, which runs as the Windows native which calls the Windows native API calls. For an example, directly from NTDLL, or if I have to call some encryption functions, I will use the bcrypt or crypt32DLL, or if I have to run some networking levels, I will use some other DLL files. Another DLL file which is advbpi 32.dll, which is highly being used in the malwares, or kernel32DLL for specific functions. So these are the static and dynamic loading of the functions. Then we have the linking, which, okay, whenever linking is being called out, always remember that this is dynamic linking, generally which is being used for the DLL injections. Then you have virtual memory and paging, which is like malware can manipulate the page tables. Okay. Address translation, which is important in translating virtual to physical offsets. Then you have swapping. This is very, very critical when it comes to memory analysis. Swapping is all these concepts are very critical when you are analyzing when you are doing the memory analysis. But swapping is very, very important because nowadays, if you see, especially in Linux or Unix-based machines, or even if or in Linux or Unix-based machines, they have done the swapping, which means that the part of the RAM is moved to the disk. Means you are only running a certain part of the processes into the RAM, but major part will be moved to the disk to increase the performance. Okay, so swapping is very, very critical. Note down this, and when you are doing the malware analysis, make sure that you collect the log. Make sure that you check if swapping is enabled. If yes, then make sure you collect the logs properly for swapping. So now we will start with our actual practical practical malware analysis. Before going to practical malware analysis, I will showcase this practically as well. So there is a very important concept which is called as the memory leak, which is called the memory leak. So this is our first point when we are doing the memory analysis of detecting the memory leaks. How this happens, what is the cause, why it is important, we will learn this, in this particular topic. So what is memory leak? A memory leak occurs when a program allocates memory dynamically using malloc, alloc, new functions. But the issue is why memory leak happens, because it never releases the memory back to the system even when there are conditions when it is not required. Okay, for an example, that you allocate a buffer, okay, to a when you allocate a buffer to a program to run inside the stack, to allocate the stack to a particular program. But what happens is that you forget to write the free cause of the memory, okay, to write the free memory after being closed. Then it start consuming the memory and start writing to the other memory locations, and you know and it doesn't release back to the system. That concept is called the memory leak. So what happens when a memory leak is there? The RAM usage increases, the RAM usage increase, possibility to exhaustion, which we'll call the deadlock situation. System performance degrades, crash or freeze. In leaky malware or injected processes can cause these symptoms either intentionally to DOS a system or due to poor coding. So in generally in older days of malware writing, malware analysis, malware development, generally malware developers, they used to intentionally put this into their code so that if they are not getting, if the firewall or their in any other system blocks the connection in to the attacker server, at least it crashes the system. So that is why memory leak is being uh, uh, invented or being inserted into the malwares. So what are the symptoms? Gradual increase in memory usage, RAM usage keeps climbing, system shutdown or high memory pressure, usually memory patterns in certain processes, tools like task manager showing even ever increasing memory for a single process. In a forensic case, stealthy persistence mechanism or process hauling may exhibit memory leaks. How we detect it? There is a tool called debug diagnosis tool. You can download it and you can attach the memory to it and to look for the memory analysis. Yes. So here I have written a small code in Python. This I will also upload it in my GitHub repository. So this is a Python code which will execute, which will start, which will start allocating the memory, running inside the memory in the form of 100 MB, per iteration. And and I will showcase that as soon as the memory gets increasing to the 100 MB, you can see the graph that is moving up and down in the form. So let's go to that. Let's see how this happens. Can I make it a full screen? Now this is my already infected machine. Okay, I can showcase you that this machine is already infected. Let it just load, and let me grab my water bottle as well. The reason why it is taking time, because the machine is infected with Medusa ransomware. So let it load completely. Just give me a minute. Hmm, Why it is transferring? Let me just restart it. Let me shut down this for some time. I think it is consuming so much of memory, but I don't know why, because all my other processes are already stopped. Let me rerun it. Let me run some memory. Okay, let me log in. Yep, because the machine is infected. All the even the VM files and everything is encrypted right now. It is just doing the loading. Just give it a minute. Come. I don't know what's the issue. Let me just pause it for a minute. Meanwhile, it will run. I will resume the video in once the machine loaded up. So, hi everyone, the machine is loaded up. So we will start with the next part for checking the memory leak. Now, if you want to see, the machine is already infected. So if I showcase you for an example, let me just disconnect this machine. I don't want any issue with my host machine. Disconnect it. Now, if you can see, everything is already encrypted. Let's go to Python folder. This I installed newly. So here, if you go to PowerShell, you can see everything is Medusa, Medusa everywhere. All files are automatic, all with this thing. And I have already this thing available that this machine is already encrypted with Medusa. If you want to pay, use a Tor browser to connect to this Onion site, and if you want to chat and all, you can use the uTalks, which is the very famous chat program for this, and this is the company identification hash for this, and this is the uTalks. So this machine we already know that is already encrypted. So the same message. If you want to look for some other folders, even at the desktop, everything is, if you see, we already is already encrypted. Okay, so let me just demonstrate here. Let me go to program files, 7-zip. You can see all files are encrypted. So this machine is already infected. So let's first go for the memory leak program. This is a very simple program which I wrote it in Python to perform the memory leakage. I will upload this as well in on my GitHub. You feel free to modify as much as you want to, but this is just to demonstrate purposes. Do not start infecting the or the colleagues' machines with that. So a very simple program to showcase. So if I want to run it, let me just run it. Memory leak.py. Now if you see, it has already started. Now if you go to the performance monitor, you can see the lag is started coming on. And in use memory, the available memory to it 5.5 GB, and it has now started to increase. Let me go to performance monitor and let me open the performance monitor, because this provides information in much deeper sense. Let me go to the program Python. Here we are running with PowerShell as well. We can add both things. PowerShell, we can also try to check if terminal is there. We will put everything in the box. Task manager. No. Let me look for CMD. No CMD running. Okay. So these two we can put a filter on, and you can see already see this. Okay. See the lines. You can see it is already being allocated. Okay. Let's look at the total lines, and let's look at the memory utilization at the backend, which gives the clear cut picture that the memory is getting leaked and it is not getting you know allocated back to the machine. Now as soon as it will be keep on running, it will crash my machine for sure. And I have like crashed this machine for testing the program for like 2-3 times, and it took almost like, and then I have to revert back to previous snapshot uh, uh, to make it happen, to get the new VM. Now if you see at the performance monitor, you can clearly see the sorry that the size is getting increased. You can see process information, committed bytes and views, available MIGs, and it is keep on increasing and decreasing. Okay, here we get proper graph, but if you look at the task manager, you can see the memory is completely filled. Okay, and in some time it will be crashed. So I will close the program intentionally, and you can see gradually, automatically it decreased. So it means at this particular point, something was increased. So what we can do when it was running, let's suppose it is still running in the PowerShell, I can go to Task Manager. So I can go to Users. I can also use the Procmon as well, or Process Explorer, but this will also suffice your thing. Let me look at we get a terminal, or we get a terminal. If I can see any Python, no. So we know that this terminal was creating the problem. We can create the dump file. Okay. Okay. So open file location. I had already tested one. So the size is pretty much same. So you can just use your debug analysis tool. You can attach the data files to it, and you can start doing the memory analysis. Now this machine is already crashed up, so I will not do it, but you can start analyzing the memory from here. Okay, so this is pretty easy and pretty cool. Whenever you are performing the memory analysis, the very first thing you should do is checking the particular uh, this memory leakage. Now we'll go to another thing, which is the memory analysis roadmap, especially when the malware is in memory. I will say infection and or malware in memory. The very first thing is like initial triage. What you can do is you can acquire the whole memory before reboot. Then you can start collecting the hashes, file names, memory user stats. You can install the Volatility 3 and obtain the correct symbols and plugins. You can use the baseline plugins like this. I will showcase these all in practical, don't worry about it. Then advanced techniques, extract memory regions for reverse engineering, for especially for reflected DLL injection, process following, ransomware key material, credential dumping, artifacts and all. We can look to all this, but Medusa has not done all these things. But it depends upon the type of malware or ransomware you are identifying. You can actually look for all this. Then you can do the IOC generation, full IP, domains, hashes, file name, mutexes, yara scan on memory regions, and you can create a report based on that. Now, this I have already showcased in many of my previous videos. Please go and check it out. You will get a lot of information from there. For this particular activity, I will only focus on the memory analysis caused with the Medusa. So we'll start with the collecting the memory dump. I will be using the MSOLs for it. So let me just open the CMD, run as administrator. Oops, actually I don't need to. I just need to go to DumpIt exe. I just need to right click it, click on run as administrator. It will automatically open the console. You can just click on yes, and it will start processing. Okay, now let me check if yep, the file is already present over here. It is processing. Let it process, but I have already collected the file. Okay, so I will keep on running. I will not waste my time anymore here, but I have already, it has already dumped the memory, on it, and we can look to the size. Let me just, uh, pull up from here. Let me go. Let me just showcase this in Kali. I have imported this in Kali now. So we'll start with the, oops, I think the machine is good. Okay, okay, done, done. Let me just reboot the machine once. It is going to take only 1 minute. I think it was updating or upgrading at the back end. I might have kept it for upgrading it. So no worries. It only takes like a minute to load up. So machine is loaded. Let me just log in once. So all these malwares are already present. The Medusa is present in this. The collected raw file. Let me just showcase it to you. Here you go. Axon.raw. Okay. Now you can see the total size collected is 5 GB because this was the size of the machine when the machine got infected. Okay. You can see this. Now we will start running our analysis. We'll go to volatility 3. Let me go to minus analysis. Volatility 3 is already present to me. So we'll start with our very first command to understand uh, what is the Windows information. The very first thing. Just a little bit size. So it is analyzing it. Let it progress. It is reading the whole image to provide the best information, although we already know that this is Windows 11. So let it run for a minute. Okay. So after analyzing, it has provided the information that the symbol for this file is being used is 64-bit. Yes. Is PAE available? No. What is the layer name? Windows Intel 32. Memory layer. This is the KD version block. Major minor version. Machine type. Key number processors that are being allocated. The system time to which when this machine was being or the image was collected at that time, the system root Windows, Windows NT, and some other information. Okay, now let me clear it. Let me run the PS list in this Windows PS list. I think this is the command. Yes. So what are the running processes? What happened? Connection disappeared. Oops, okay. So something about it. Let me just see settings. It's not taking it from here. I don't know what's the issue. Fire version 2. This is fine. Something fine. Maybe some custom CD plugins. Windows. Sudo remove. Let's go back. Let's go back. Now let's try to run it. Let me re-get the volatility 3. Uh, it has a lot of things. So like this file, let me just take it a backup first. Sudo remove volatility 3. Sudo volatility 3. It's not going well. Let's check. Sudo check clone. It's already there. Fine. 3. Okay, so we have the new version, new files for the volatility. Sudo -3. Now let's run the PS list. I think it will work, because what happens at the back end is I keep on creating a lot of custom code, custom files, custom things at the back end, and sometimes I do mess up with the original py files. So this is the problem with me. I keep on doing something at the back end, and many times it gets mixed and missed, that I forget to update the files before. But no worries, it's okay. It's all with everyone who loves to write their custom codes or to automate a lot of stuff. Hmm. So let it run for a few minutes. And here we got all the processes list that were running at the time of collection. So we have registry running at that time. These are normal windows. We have LSS. We have will login, memory compression file, DLL host, explorer.exe, user initial, user init, uh, Terabox processes. I know because I have already analyzed it, but this could be suspicious. MSH, your broker, and DumpIt.exe, and so on. Okay, let's look if we can get cmd.exe or PowerShell. Let me just clear it. So we can just grab cmd.exe, and we have cmd.exe running over here. Okay. Next, do the PS scan, which will provide a better output for the PS list. So what are the program what are the PIDs, what are the PPIDs, thread handle sessions, create time, exit time, and the file output, and especially the offset. So give it a minute. Meanwhile, let me just close this Windows. I don't need it anymore. Done. I think it is taking too much of the data payloads. Let me just clear it out, and let's do the scan against the cmd.exe, because that is our target. This thing, PDB scanning progress, because this is a new initialization of the image. There is no cache present for this, so definitely it is going to take some time. Meanwhile, We'll meanwhile let it complete. Meanwhile we will run for the command line, that the commands that are being ran. So let me just copy it from here. Let it run. Let's run the PS scan completely only, so that nothing can be missed and we will be knowing what to look for. Let it run. Let's run the command line, cmd line. Let it run, and these are the command lines that are being run. So what I usually do is I save all these details in a text file. So cmd line dot txt y sudo chmod 7 cmd line dot exe. Completed. Now meanwhile let's look for the command line dot txt, what it has extracted. So let it open this. So let's start analyzing what is there. So this is the process id, or this could be interesting. Will log on also, else as this is normal Windows decom launch. This is for network service, local service, sans, just click tor. Oh, okay, this is office click 1. This is Windows native Wondershell. This is VMware process. This is DL Windows. Now it is calling some process ID. This could be interesting. We can look for Google what this process ID is. Then something interesting. This could be interesting. Now I know this is for TerraBox, but if that was related to some malware, it could be interesting, and it is running with command with no sandbox. But for this we can ignore. Now this could be interesting. CMD is running. Okay, let's search with something with Medusa is there or not. Find all. There is no Medusa. Let me just go here. Okay, there is nothing as Medusa in this, so I will close it. This has now completed. So it is giving us the complete information when any process is being run. What are the processes? Like for example, this net.exe. This would be very, very interesting if there are certain command and controls that are being done. Now let's look at the DLL list. So let's clear this DLL list. Let me see DLL list.txt. Let me save all the output in the text file so it becomes easy for us to analyze it. Now this plugin also takes a bit of time because it will analyze all the DLLs in the particular EXs which were being utilized. So let's look at the DLL list. So these are the DLLs which were being called out with each and every process. So let's look for cmd.exe. These are the DLLs to which we have looked for. So you can save this in Excel file for the complete information. You can see that the base DLLs are being called, but if you see, some other DLLs are also being called which shouldn't be part of this. So it means there is something interesting going on in this particular uh, uh, exe file. Now the process ID is 7896. So let's look for the specific process ID. So what we can do is we can put a filter to process ID 7896, and it will give the complete information about the required DLL. So we can get the COM base, CMD EX, CMD XP DLL, Win32, Win32 DLL, and so on. Now let's do a net scan that whether this particular ransomware tries to connect to the external side. So at the time of collection, the machine was in the isolated zone, because as soon as something happens, the machine should always be put on no adapter with isolated zone, so that it should not connect to any other machine in the environment. So let's look if any of the network scanning is being identified. Why is it taking time? This plugin should not take much time. Meanwhile, let's look for the handles. Let's store it in the handles.txt file. Okay, no addresses were being identified. Let's look at if we can get something in the handles. Let's give it a minute. Okay, so handles are done. Let's open it in Sublime mode. Handles.txt. We got the offset value. This is very, very critical. Now I understand the offset values very clearly. These are the pointers at which the particular process with the allocation to process ID is being run. So the very first processes are for the systems, and then you will get for the user-based processes. Okay. Our pointer is to look mainly for CMD or PowerShell here, because I ran it from the CMD. So I got cmd.exe running at the process ID 7896 with the system process of 4, and this is the basically the offset value for this, and this is the offset ID. So this is very, very critical to know the when you are doing the malware analysis, because this will go into your evidences. Let's go to another, then another, then another, because with this you have to create the particular value type. Now if you see this, the very first event that is being loaded to this particular offset, and then it is running with the Windows functions, IR time, TP worker factory, collection, timer, wait. Now it is writing, Now it is storing the registry key here. So this becomes very important. We will copy this registry key to understand what is being stored in the code page. Then it connect to the file in the device called drv connect. Then reference. Then ALPC port this. Then registration. Then the mutant is being called out at the while staging underscore 02, and this is the semaphore, the directory to which uh, uh, call the named objects from this, and this is another registry to look for, and then we have certain events, another registry, and here is the system32 file which was being called, and something from desktop it ran. So here is the Medusa which was being called on. So here, now this is very important. Okay, so we got our first trace that it loaded something from Medusa directory with the directory Medusa sample. Now let's look for Medusa directly. So Medusa here, we have two samples for Medusa. This, so we know that our prime target to look is for the process ID 7896. Now let's go back and let's run the handle ID with process ID 78, sorry, process ID 7896, and here we got our reference points. Okay, so this is the key registry that we need to look for. Let me just copy this, actually all, but I know right now because I have done this multiple times. So I will look for this print key. Let me just store it somewhere. I just paste it in a notepad file. Let's run for the registry. Let's go for the file scan now. Sudo handles. Let's do the file scan. Complete. Let's store the file scan in this, in a text file, so the analysis becomes easy. And why storing in text file? Because you have to provide the evidences when you are writing the report. For an example, many organizations they file the lawsuit, especially when you are in US or Europe side. They generally do not leave the culprits. What they do is they file the case in the they file a lawsuit, and these evidences are very much required in those lawsuits. So give it a minute. The file scan plugin generally takes a lot of time because it will be keep on searching in a lot of in all the places. It will take out of the information from all the places wherever the files and directories and the file system will be stored. Meanwhile, let's run another plugin which is the malfind. and then we run the mal find. Let's save the mal find in a text file so that by the time we should be completed, we should not waste more time in that. Let's look for some of the, what I suggest is let it complete. Meanwhile, what I will do, let me search for some of the threads. Let me just copy this command. Let me look for the Windows threads. Let me store these in text file. Windows threads. txt. So file scan is completed. Sudo sublime complete file scan. And if you see, these are all the files which were being called out. Let's look for Medusa. Here is one file. We can see there are 18 matches. Let's look for the Medusa another. Here, this is my file. Medusa sample. Here is a Medusa malware looks being downloaded. This is another readme file for Medusa, Medusa. This looks a bit tricky because it is connecting to the Microsoft Edge. This could be interesting. Here is the zip file, I think got extracted. Medusa.txt and so on. So let's look for something .temp file or something with .med. I think it has a lot of interest, there's a lot of some use. Let's grab it, some temp file -i.medusa, and I will not search for dot, I will only search for Medusa, and then complete file scan, and here we go with all the information. Okay, now let's look at if this is not yet completed. Okay, let's look for Windows threads. Sudo grep -i. If something is running with Medusa, Windows threads, nothing. If something is running with CMD, CMD we got it because it's a thread, it's a process, and it is running with this. Let's look at something which could be interesting in Windows threads, because it will come with the timelines at what time it is these were being running. So this is very, very critical. Let me just close these files, these are not required, and delete previous list. This one is previous. Okay, from a previous video. Then we can look for the some of the registries. Meanwhile, let Medusa completed. So let it run, I think, hive scan. I will not do the hive scan. Hive scan only provide the what we call it as offsets only. So let's Oops, something is wrong here. Oops, the command is wrong. It should be with the registry file list. Let me just save this file list and Windows under txt, same sudo sublime and file list. And here we got the complete machine user information, what all user files are being present. If now this is very important, if let's suppose some users are being created or anything, the information will be present in these registries. Okay, nothing of much concern. Let's do the Windows registry print screen. Oh, sorry, Windows registry print key registry underscore print key.txt. Let's look at registry print key. So it has given all the registries. Now let's look at our registry. Let me just grab that user. Oh, oops, zero plus minus nine. That user. Then I will call registry. Nothing. Let me search for something with med. Med is there, but it is of no use to us. Let's look at the callbacks. What are the callbacks to the memory? Windows, the command is wrong. It should be windows.callbacks. So these are the callbacks. You can look for the callback with all the information. Let me store all the Windows callbacks in a text file. Meanwhile, let it complete. Malfind is completed. Let's open the Malfind. Okay, we got a lot of information here. Let's look for Medusa. Nothing is there. cmd.exe. Nothing is there. cmd. Nothing is there. So we need to go one by one for this. Now I will not go into this. You can look for in this. Let me just do some tricks. Let me just teach you some tricks here. If you get something like this, ref minus I dot temp, nothing there. You can search for tmp, nothing. Okay. Or so one particular thing what I have created is the custom yara file. Let me just sudo copy the yara file and analysis related to custom yara detection here. So let me showcase you the custom yara detection file. So what I did, I have created the custom yara detection file. So what it will do, it will automatically scan. You can add your own detection rules over here. That is easy. What I kept is very easy, that I wanted to create. I wanted to have this yara file that remains with me all the time whenever I am looking for the yara detection for the Medusa. So what I will do, I will run Windows yara, yeah, that is the plugin name, and it will automatically scan for if there is any Medusa uh, traits or Medusa information present in the image file. So let it run. Meanwhile, let me copy the custom. So let's look to, first of all, let me complete this. So if you can see, it has already provided you the offset, process ID, Medusa ransomware. The information is Bitcoin is present, dot Medusa, Bitcoin, Bitcoin dot Medusa at all these offsets values. Now what you can do is, whatever we have done this, we can actually automate it. Okay, how? I have written a auto triage file for Medusa with all the base, and it is written very simple. Okay, I didn't okay, my style of writing code is like, is very simple and straightforward. I don't do mumbo jumbo stuff, you know, putting it color code, making it more fancy, making with coming with the fancy stars and all of that. My style of writing code is very simple, to the to the point and straightforward. What I wanted to showcase is this. So the very first is that you provide the raw file, or the bin file or the image file which you have created. This is the Yara detection rule Yara file. So you can give the path as well for this. Now let me give the complete path, pwd. There we go. Usually it will take it, but just for for this detection. So let me just copy it, and let me just paste this. So done. The directory name will be volume underscore output. This is just for printing screen. Memory, it is to load the memory image and the output directory here. So what commands I'm running? Processes listing, command lines, reflective DLL, Windows handles, okay, any that to find out any ransom notes or something. Image file, file scanning, injected code, then registry hives. I need persistence is there, rogue services, okay, so and running with the Yara. Yara. So let me save this. So what you need to do is chmod +6. Usually I give 777. Like to. Oops, I don't like to keep it in any other way. So I think Medusa auto tries sudo run Medusa auto tries. It will start running each and everything. Okay. Let me just interrupt it, and let me just go to the volume output directory it has created. Now see this, it has already started running the things. Okay, so it usually takes time. So what I have done, I have already saved an output in this. So we have all the information over here. So for an example, I want to see what is there in the hive. So sudo sublime hive.txt. Maybe trash. Let's look for command line. Sorry, sudo sublime cmd9.txt, and you will get all the command lines saved over here. Okay, so you can run this. You can modify the uh, code as per your wish. Uh, it is up to you how you want to use it, how you want to store it. But this code I have written it to ease my life and everything. Now if you see, it is keep on running. Whatever we have done till now, it will give you an automation in your code. So you run it once and automatically it will provide the output. I hope you enjoyed this video, and I hope you are enjoying my other videos. I would suggest, just for something, that go purchase my book. If you like my videos and tutorials, I have written a lot of stuff in my book as well. So you can go and check it out. I hope you enjoyed the video. I will come up with new video tutorials. My next target is to cover completely on the cloud native security. So my next video might come on Kubernetes. I am planning to start a complete Kubernetes series. First, I will do with the Kubernetes threat hunting. Then I will go for the Kubernetes compliance and the pen testing as well, because that is the area which I like a lot now these days, which is DevSecOps. I have created a lot of security pipelines, automated a lot of security stuff using DevSecOps, not only like SAST or or DAST in this, but I have the infrastructure code scanning or all this stuff, but I have added a lot of things. So in coming months or in coming weeks, you will see a lot of interesting stuff in this chat on this channel. I hope you enjoy my videos. Keep liking, sharing, and subscribing my channel. It gives me a boost. Thank you, everyone. I hope you have a nice and happy weekend.